Welcome. EDURange, a framework for the development of cybersecurity exercises. My name is Jens Macher, and this is Miles. We are from Lewis and Clark College in Portland, Oregon, and our collaborators from Evergreen State College unfortunately couldn't fly on Sundays. So if there are questions, they're here on Skype, so I think they help us answer it. So this is an initiative that is NSF sponsored. It started about a year and a half ago, and we kind of come from the security mindset philosophy that for students to really get security right, it would be great if they learn how to don't trust interfaces, because sometimes you don't see everything, or what you read might not be the whole story. There might be other ways to do things. To definitely don't trust the input from the user, everything from SQL injection and so on. And also to understand how things fail, and that this is often an opportunity to not to kind of fail open from the attacker side, and as a defender that you kind of understand how things can fail and how they can then still take advantage of that. And so the students should question all their assumptions, our assumptions, everything. So with those four kind of mindset philosophies, on the next slide, we have what we try to do. So we wanted to build some hands-on exercises where we, with the students, learn this mindset. And so we are not the only player in town, we already know. So we just built something, but we also looked what other people have. And so you maybe saw the RACE presentation from Winnie Nestler's book yesterday, or you might have heard about cyber thieves from the military. There's some simulation about firewalls. Seed, people have a nice set of exercises. Google has set up some application that has holes. OVAS, WebGoat does some nice exercises. Packet Wars, Miles and I, and everybody's played a couple months ago, and actually won. We would like the exercises to be competitive and collaborative, hands-on, because that way students seem to be learning better. It ties into the keynote this morning as well. And so we have something somewhat working right now, and we think there's some social components, it's network interactive, and we kind of want to play it with you today.
Yeah, so EDURange is this framework for the development of cybersecurity exercises. As Jen said, it's NSF funded, and the goal is to automate the creation of these training games. So we have a spec that we can write very easily and have machines spun up on the Amazon Web Services Elastic Compute Cloud, which is a paid service that we have a grant from Amazon to do for education. So we can have these machines spun up, drop of a hat, in the network configurations that we want as per YAML spec that we write. So we have a demo scenario. I'm going to explain more of the tech behind EDURange after the demo. So it's a reconnaissance exercise, as I said earlier, using Nmap. We're scanning a /17 network in insider notation. So there are 32,768 possible locations that hosts could be at. And we are trying to find the 13 hosts that are hidden somewhere in this possible range of hosts.
It's like needle in a haystack.
Exactly. And so the goal is to efficiently use Nmap to do this. If you have experience with Nmap, it might not be that complicated. If you have no experience, my advice is to start small and scan some of the smaller networks that might be available, like a /24 network, subnet of this larger network. And so the first step is to navigate. I don't know if you can read this, but it says it's on the board as well. 54.209.29.222 in your web browser, and that's a shell in a box that we have running for you, that you can then connect to this IP, which is on our local network that we've just spun up using EDURange. And from there, you should be able to scan the network that we have set up. So I'll walk around and help.
Raise your hand if you need help, but please log in. Log in, open up a browser, doesn't matter which one. And so this is your URL, so in a browser.
Yes.
This is your URL. And to not let anybody in, you have a little password, login and password, and so it has to be my first name, both login and password. So then you're on the Amazon EC2 side, on the kind of the gateway node, but then you SSH to, and here we all share the same computer and have the same password. So these are login and password, this is the password. Once you're there, you get your prompt. For some of the things you do, it's nice to have root. So sudo su gives you root. Let's see where people are at.
So my advice is to pull up. Okay. So press enter. It looks like. Whereas I would say don't use internet. That might be the issue.
Okay, so Chrome is working. Somebody has this working on Chrome?
Yeah.
It works on Chrome.
Yeah. 5.4.2.9.
So here would be the URL.
So again,
It asks you for the login. Password is the same. After some splash screen,
okay. So you want to SSH into 10.0.128.21. And so you start out at this gateway machine, which is web accessible, and now you're logging into a machine that is on the network that was created. And then from there, you're going to be scanning the larger subnet. So this actually should be.
doesn't matter.
Yeah, you can do this, but it actually only goes to 127.255. So this is the range of the network. This is the maximum address that will be available in this class 17, and this is according to CIDR notation. I don't know if you're
I would say a little more, we'll give a little more background for people who are a little bit rusty on the subnets and whatnot, IP addresses. But the idea is, for the next maybe 10-20 minutes, think like you're a student, okay? I guess most of you are instructors, but let's assume now you're a student, you're teaching this next time.
Do I have to know this? Why do I have to know this?
Exactly. So you pretty much have to log in, but once you're here, after this step, and you become root, now your task is think about what the attackers are doing. That's a nice paper with the kill chain. So there was some recon, some reconnaissance. So for some reason, maybe they figured out this is your company. Your company is at this IP address that they have 10.0.00, and all the rest of the 17 bits after 17 bits things are not fixed anymore. That your company, this is your target. And so what the attackers are doing often is, they want to get in, they now have to actually find some live IP addresses on the target. So now this is kind of competitive, that why don't you guys speak up whenever you find
we're trying to
a machine inside this range.
These options are relevant to us.
But the question about the kill chain and what the attackers are doing, so if you know yourself and if you know your enemy, you can win every battle. Okay, so here, in a class, you should kind of, for now, maybe pretend you're the penetration tester or the attacker, that we know our company's IP range,
for example,
and your task is find the 13 IP addresses that are live.
So if you press space and then dash lowercase capital P, that gets you the, or S, sorry, capital P, that gets you the ping scan that we just saw in the options. So ping scan is a decent starting location. Some hosts might have ICMP block, so they're not going to be able to do things. But my advice is to start with a chunk of the network. So you could say maybe one of the subnets that are off of this. So again, this goes from 0 all the way up to 127, including 127. So, and within there are 255 hosts for each of those 127 subnets. And so what we're trying to do is find out where the 13 hosts are hidden in one grid. So maybe you could do like the first 5 subnets, and you can do that simply with like a 1-5 to indicate that you're going from 1 to 5. So if you start with 10.0 1-5.
So the problem is if you actually type the command that I typed in, it will take minutes, if not hours. Okay? So I want you to kind of become creative and think about what you can do. If you don't want to wait hours, there's a competition here, right? Who can find it first? So Mike's already giving some hints. But the obvious way would be if you just type nmap on its own, it gives a little splash screen like nmap.h, or you can read the man page. Or as part of this one, it actually says on top that there's more information at a URL at nmap.org. Okay? And there's some examples. So
if you run nmap-h, it'll display the help information. Yeah.
Or just nmap by itself works too. So if some students would know nothing and would start typing the command they have on the board, you can hit the key like the space bar once in a while. Let's see whether it works here. So enter. And it gives you how long it's been running. So I've been running for 21 seconds. It has 0 hosts completed. It found 0 that are up. It does a couple at a time. There's a ping scan here. But it says it's only 0.64% done. So it needs 200 times longer than my half a minute here. So it would be like 100 minutes. So this is not very good. Often it's like capture flag, maybe the first one or whatnot. So you should maybe try some other things. So it expects, but this is probably standard time, but it takes another 53 minutes to be done. So maybe Control C out of it and think about what else you can do than scanning this whole network by itself. So maybe now I should talk a little bit more people who don't know what this notation means, what a net mask is. So normally net mask is used if you have an IP address 1.2.3.4. So the IPv4, maybe we should say this first. The IPv4, we have those dotted quads, where each number here is 8 bits long, times 4, we have 32 bits. If you want to know, say this is me, and where I want to go is at 1.2.4.5, how do I know whether I'm on the same network as where I want to go? So this is like source and destination. Source and destination, this is all TCP/IP theory. The IP address is divided into a network portion and a host portion. And often this is about the boundaries where the dots are, because it's so much easier for us humans to do with the 8 bits with a number between 0 and 255. Because these are the numbers I can do with 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. The values are all 2 to the 0, 2 to the 1, 2 to the 2, or 1, 2, 4, 8, 16, 32, 64, 128. The largest number I can have is 1 less the next number, 256. So with 8 bits, I can represent numbers between 0, all zeros, and 255, all ones. Okay, so when I see an IP address, they normally write this dotted quads. They're going to write actually a decimal number, 4 decimal numbers between 3 dots. And so if those computers here have a net mask on the same network, some people said 1.2.x.x, where I don't care about the last numbers, then those two computers will be in the same network, 1.2.3.4 and 1.2.4.5. Okay, so some people could think like maybe this is here, my network is 1.2 point whatever. So what they might instead is they write a slash behind it and say how many bits are fixed. So this would be a /60 network. If I only have the first 2 octets, two part of the quad, 8 bits fixed, then we call it a /16 network. So what you're given is a /17. So it means also the first bit of this number is fixed. It's a 0. But overall, you can compute it by 32 minus 17 is what? 15? There are 15 bits which are for the host that are on the same network. That's why I might write down it's the highest number I can build when I now set my last 15 bits on. The 128, however, that one was the 17th one, that one was fixed at the 0. That's why when I turn it all on, I get 64 plus 32 plus blah blah blah. I get one less than this one, I get 127. So your task is to find the IP addresses that are alive between 10.0.00 and 10.0.2725. So one idea you can do it, you can say just nmap, you can say like, oh, I think I know where it is, I Control-C out of it, I will just say nmap 10.00, and it comes back in 3 seconds. That's better than my 53 minutes, right? But I only tried 1, okay? So what you may do instead is like, okay, let me try a little bit more. Let me maybe try the /24. That was 24. That's 8 plus 8 plus 8. I'm only leaving the last 8 open. So this will now scan me the 0.0.0.0 all the way to 10.00 to 255. So that will scan now 256, and maybe it comes back between my 3 seconds and 53 minutes. So as I hit enter, it now thinks, okay, I'm taking 3 more. It takes about, well, I did 17 seconds plus another 3 minutes, so it takes 3.5 minutes. So I'm already better. But I also maybe want you to Control-C out of it, or can let it run. When you look at the main page, -H or main page or just nmap, it has more information. It first starts out with saying that you can specify the targets, and we're a little bit off screen here. And this much we use the dash notation, we use /24 or whatever. You can, it discovers hosts. So if you want to, if you don't want to have DNS be in the way, you can actually turn this off, so maybe it makes it a little bit faster. There are other things here. So what does it actually do to your machine? Your machine, when it reaches the IP, it now has to actually select the port, right? Because your machine might be open for business as what? A web server, a mail server, you can FTP to it or something like that, right? And maybe it's running DNS, it's a domain name system or so. So how does it kind of figure out all your ports? And if you remember TCP, the SYN/SYN/ACK three-way handshake, you can actually specify to nmap how far into this three-way handshake it should go. Maybe you don't want to go too far in because 1, it takes time, and 2, they might log you. Okay? So maybe you can make it faster by just saying, well, I just want to send a scan. However, wouldn't it be even good enough to maybe just find out, are they open for business? So can I ping them? So there is also a ping scan if you want to. So up here, -SP, you can just see whether you can ping them. The other options you have in here, you can go into fast mode. So it tries out a few other things. Thank you. Or you can actually get more information about the services, or you can use scripts, or you can even detect things. You can try to figure out what operating system is running. And I would say those things I would do later. Once I've found the needle in the haystack, then I would add those options. You know, when I say, okay, I found one. Did anybody find one yet? You found one? Say the number, mate?
10.0.3.3.
3.3. Somebody else find 3.3?
Yeah.
Did you use some flags, or did you just let it run?
I just did a ping scan. I could then.
So he used a ping scan. So that probably went faster. Okay. So what you can try out is, just like my own slash, what did I have before? I should click on it. My nmap 24 took, I forgot how long it was. That was actually too slow, the 24. Or when I just scanned one machine, it took, what, 3 seconds?
Yeah.
And if I change it to the ping scan, minus SP it was, right? Lowercase s, big uppercase P.
Yep.
Then, here for the one machine, it might not have much, 3.001 seconds. But now I believe, if I go a little higher, say, and he found it in the 3 network, so maybe it's just say 3.024. So now, it will try all the 3.x's. So it will try out 10.0.3./24 means 32 minus 24 is 8. The last 8 bits are open, and actually I can confirm that you have the right answer. But if I hadn't used the minus SP, that was what I was at before, when it was, I forgot what it was 3 minutes or so, and it reduced this to 4 seconds. So we have a winner. Not only did he find the first out of 13 machines, but I like your strategy. You're thinking that you kind of drove and mapped. You looked up the man page, maybe you knew it before, but now with a... You found another one? Who has questions about this thing here? So we found a 3.3 machine, and one way for you guys to catch up or verify this, okay? You are not looking at the whole range. You're looking just at a /24. So you're just looking for it at the 3.x subset. With /24, 8 bits being open, so 3 dots, the R slash being open. But with minus SP, you can reduce the 3 minutes to 4 seconds. Isn't that nice? So if you read the web page some more, maybe you can even do more things. It's still up here. Somebody see something else interesting?
And so part of that is...
Anybody find some other interesting flags?
So different scans will have different...
Yeah. We could do TCP and UDP port scans, and then service, vendor, and detection.
Now that you found it, exactly that's what the hackers do next, right? So you can kind of outside our kind of find the next 13. You can now say like, okay, I found the 3.3, but I didn't find much about it. So there is a nice flag, but it takes more time. If you then, for example, add the minus capital A, that gives you pretty much everything, all, somewhat. Now it will tell you more, but it takes a little bit more. It will tell you what actually ports are open. So as an attacker, I will now see, oh, this machine is alive. How can I get in? And so maybe now I'm going to talk a little bit more. I just click on it. So what it did here is, for me, it actually finds some fingerprints. But most interestingly here, it has TCP port 22, which default-wise is SSH. We don't know for sure, but then what it does is actually goes in there and actually tries to do some more testing and really find some SSH host keys, DSA, RSA. It tried to guesstimate what the operating system is, and it couldn't find a good hint of it. And it even shows some other kind of fingerprints up here. It says it's one distance away. How would it know that one?
It's on the same network.
It's on the same network, and maybe there's a time to live, kind of when it does a ping. Yeah, sometimes you actually echo things back. And let's see what else. You did a trace route. Yes, that's how you saw it here. So once you find something, you think just as the attacker or even as a defender or pen tester, you can do more things with it. And so that Nmap kind of has some nice option, but it would make it slower. So it took me 14 seconds just for one machine, but now you want to actually spend that time, right? Think about resource management. I only want to spend maybe 4 seconds to try out the whole 3.x, all those 250 machines, to just see who's alive. But then I'm willing to spend, say, 14 seconds on that particular one that I found, because now I want to kind of find out the juicy stuff and kind of get ready for my next step, do things, okay? So if you guys are teaching, see this as, or what Vanessa said, take them to the dog park, okay? And now let them run. Whoever saw the presentation on yesterday, right? Don't be a dog walker.
That's a good one.
Okay.
Are these are your boxes?
Yes.
Amazon Web Service, just spun them up on Amazon EC2. So you can do this too. If you're an educator, contact them. They give you a certain contingent. They might still need your credit card. They're normally nickel and dime people. So we spun those things up. There's 13 machines plus player machines. Right now, you all are on the same player machine. For scoring later, we might actually give you your own machine. And you can see this is outside the range. This is at 128. But we just spun up 13 plus X machines on Amazon just a couple minutes ago. And now they're nickel and dime us. But as educators, they give you a free amount of money. I think it's like it's only students you have and whatnot. and then we can forward later. We have a YAML file like XML where we specify, what are the player's machine, where are those certain things hidden, and so we can have the game. The idea is also about competitions, that it's repeatable, that we can just change our file a little bit, start the thing the next hour or the next day, and now students who were maybe last finding the 3.3 machine or whatever, they now learn about it, do it again, but it's different. They can now kind of rinse and repeat.
Two comments. One thing I do like when I'm teaching the students about the MS scan, send it to a text file, and then you don't have to, then you just for your future, your future endeavors.
So what's the flag for that?
You can just do like the greater than.
Oh, just redirect it?
Redirect it.
Oh, good. Good.
I think there's some MS commands.
Right, that's some commands.
Yeah. And one warning about Amazon, I had one of the Amazon groups, and so the students set up some password crackers, turned the machines off, and they didn't, and I forgot to check.
And so you charged you.
And go out of my own pocket because I had my own credit card in there.
Yeah.
But it's great tool, but
so they want a credit card like Apple, and everybody wants a credit card, right? But I like this song, 99 cents, whatever. So normally it's nickel diming, but what you can do is maybe then after class either shut things down or ask them nicely to maybe say, oh, oops, it was a mistake, Because the business model is to make money not out of education. The business model is to make money out of business or so. But we can recommend it. So that was a learning curve for us. Might say some more. But before I finish here, and might say some technical things, do you think this is fun for your students? Yeah. Okay. So it really is who has found the most. So we know that you found 3.3, and you said you used NMAP before. Did somebody find some other IP addresses?
I didn't find any on 0, 1, or 2.
Okay.
I'm trying.
I got 4.
You got 4. So you guys can actually run this in the background. Besides the -SP, there's also the T. It went away for like aggressive. So if you go back to the main page, there is this thing about, let's see where it is. Here T is the timing. So higher is faster. So T5 is the fastest. The other thing you can do is, and then I'm going to stop talking, also if you want to do it, if you have Wireshark, you can run Wireshark in the background and look at it. Here I only have command line things. What I'm going to use instead of Wireshark, I'm going to use TCP dump. So what I'm going to type in, TCP dump. I can look up the flags. So first I have to type really. TCP dump. -W write it to a file. So I'm going to say whatever file name it is, my file 1 or whatnot. And ampersand the background. So if you only have one shell, now it runs the background. Now I'm going to rerun my old command, whatever it was I did last time. Maybe I did let me do another one, where I do the ping scan of the 3 network with 24 things in here. This took, what, 4 seconds? So wait, I'm going to count to 4. It took 3.9 seconds. I'm going to put it back in the foreground, FG. I Control-C out of it. So now what do I have I have my file 1 that now listens to all the packets that I send out. So in 4 seconds, I found the 3.3 machine, but if students are curious, if they really have this hacker mindset, they want to know what's going on under the hood, right? Then now I can, with TCP dump with a different flag, I think with -R, I can now read the file, and I can probably paste it into more or grep, look at certain things, but I would see that here actually was all TCP, ICMP echo requests and replies, because I told Nmap just do the -SP thing here, okay? And so this is now a long list. I forgot how many packets there were, because we just try them more than one time. And you guys ping things. Sometimes the first ping doesn't go through, right? So there were 256 addresses in that /24, and it probably is a little bit more than one ping each. So now you can do your analysis, you can word count, you can grab certain things or whatnot. But for the students, dog park, the more advanced, then can really figure out, oh, what does Nmap really do? If I'm a good programmer, if I know Scapy or some other tools, I can write my own Nmap. I'm not just a script kiddie, but I can also maybe drive it better. I know I can learn those options, and if I really want to, I can really see what's going on under the hood. I can use my TCP IP knowledge. I can be an intrusion analyst. I can really look at the bits. If I want to, there's a PCAP, or can write to a file, can open this in Wireshark, and then have Wireshark help me as a little expert system to really look at things. But this is really what's going on behind the hood. It's really I'm taking away a little bit of the layer from before. Oh, it's just a tool. I don't know what it's doing. I just learned it. The difference between training and education here.
Yeah. And so, sorry.
So what is we're running this as Amazon Web Services?
Yes.
So you folks, what is it that's developed with the MSF right now?
Yeah.
Next slide, huh?
Yeah. So it's a project called EDURange. Actually, the next slide is the demo cheat sheet. So this is sort of the answers to the demo, the different host locations and the commands that will find everything in under 5 minutes. That's all. Yeah, so these are all those different hosts that you could have found on the demo.
How do I go full screen?
Bottom right.
F5?
Yeah.
Okay.
Yeah, so this command, the idea is that it's doing a ping scan with SYN packets only. So it's only sending the SYN portion of a TCP connection. T5 is, again, aggressiveness on full. It just so happens that all of our instances have SSH open, so I'm specifying port 22 with that -P flag. And then other than that, it's scanning the entire network.
Maybe it's not the fastest, but this is very fast. You can challenge that. So students can challenge. It's like, hey, I found a faster way. This thing maybe took, whatever, 2 minutes, and then a student can get a little badge or some other little thing from me if they found even a faster way than we found. But this seemed to be pretty fast. And here, port 22 seems to make sense because when Amazon spin up things, you don't want to have a zombie. You want to interact with it somehow. So telnet, not good. SSH, good. What's its default SSH port? 22. So we could make it harder in the future, where you can have the 13th machine or whatnot on a non-default, SSH port, and so they wouldn't find it through this scan. But there is definitely some resource management about you might miss some. Sometimes if the ping doesn't go through, it might not even then try the ports or so. And so I have to look this up myself. I know this is a good one. And if you don't just do ping, if you look at ports, it's good to not pick them all, or even have them pick the most successful 100 or 1,000, because a port is a 16-bit number, and so there's 64K UDP ports and there's 64K TCP ports. And so this will be the answer. This is just one way to sort it, but maybe some of you found some of the other numbers. If it starts from the beginning, I think 3.3 is the lowest, and then it's like 5.5 or whatnot.
I've played some similar scenarios where you start with the reconnaissance step and then you have to move into exploitation, that kind of thing. And so getting like core Nmap skills down is really nice to have.
It's got the flags. Whoever comes there first might then kind of patch this machine or somehow block other people or so. So sometimes it pays to be faster and to know more about Nmap. So here I really want to use this not only to teach Nmap, to teach those mindset things, and maybe remind them about IP addresses and net masks and all those nice bit fiddling, even like the powers of twos.
Yeah. So talking more about EDURange. So again, EDURange is this framework for the development of cybersecurity scenarios. It's open source. It's written in Ruby on Rails. We're using Amazon's Elastic Compute Cloud and Chef to spin up instances per specification. Chef is an excellent sysadmin software. It lets you basically configure software packages that you want to be installed with VMs when you want them booted up, and so things are just there when you want them there.
Yes.
Yeah, we've used Puppet in the past, actually. Chef is Ruby, and we like Ruby, and so we shifted. And so you can write specifications in YAML where you're literally just saying, this is what I want on my machine. This is the IP that I want it to have. There are AMIs, which are effectively just the image that you're using on AWS for your machine, and you can easily specify like any operating system, any packages that you want installed. And this is all just easily configurable using EDURange. You can connect to these machines using SSH. As we've showed, we had a gateway on the internet that anyone can access, and then from there you can access our private network. So this is what a little bit of the specification code looks like. This is actually just pulled directly from our GitHub. I just screenshotted it earlier. So here, this is defining an individual battle node. So this is actually a host that was on 10.0.8.8. And you can see it's using this AMI. So this is the image that it's running from. And it has software that was installed just as simply as saying, here we've defined the software package as battle node 1 software. And all of these can now be rubber stamped with that exact same software. And we specify an IP address there as well. So network declaration, also easy. Actually, I should start with subnet declaration. So you can specify the range using CIDR notation. You can say which instances you want to be in a given subnet very easily. And then networks are just as easily formed in this YAML. You can say, okay, I want a network to link these two subnets so that they're connected. So the specification for designing these scenarios is very convenient, and it's pretty much as easy as what you see here. Yeah.
So how are the subnets linked? Are they routed together? Are they firewall? Or what's behind the scenes?
Yeah. So Amazon lets you create links between different networks that are actually separate entities in EC2. And so what we did is automated that process using their API, so it just routes them together. Yeah, it's like creating an interface between the two networks. Yeah.
Are those subnets publicly accessible, or are they inside a virtual private cloud?
They're in WPC.
Okay.
So the smallest you would use is slide 24, and so here for some other games, we put the different players onto different subnets. The smallest, it was 28 is the smallest you can do. So for some other games, besides this game, today you were all on the same node here, but somebody want to keep the students separated, and so that's why we did it here, kind of to maybe do also other attacks, or when we don't want them to listening in. Right now you could have, some people could just lean back and see what other people are doing, kind of, and listen to their backsplatter things and whatnot. You know, you could just like sit back and see what the other person is doing work for you, kind of. You know, say, oh, they found 3.3, or I see 2.
Can you run this in arrays, you know, and run this behind the scenes, you know, with building VMs and all?
That's why we don't want to build the RAID VMs. So these are live machines, so Amazon will spin them up for us.
So the idea is that we're using the Amazon Web Services API to spin this up. So it is all through Amazon's setup. It's not really portable to RAID.
So we don't need the vSphere client. I like it. This is now through a browser, so my students can do this at home. With the RAID right now, you have to run Windows, and you have to get the vSphere client. And then you have to kind of ask, we need to spin up those things for your classes. So here, besides that I gave a credit card, I'm in control of everything.
Yeah.
No Nestler in the room.
The really nice element of this is that anyone can run EDURange and use it to spin up machines on command, and very easily shut them all down, so that if you're in a classroom environment or a lab environment, you can just say, here, I want these machines right now, and then when your class is over, or your lab time is over, just shut them down. And everything is just dynamically configurable. If you want to change an IP address, you can just change it in the YAML file, save it, and you're good.
All right, so like right now, when I want to do like a demo or something, or I want to have my students try to do something, I'll pull out, I've got like, I don't know how many dozens or more of VMs I have. I probably have hundreds of VMs. I don't even know how to log into them anymore.
Yeah.
But I'll spin up 3 or 4 of them. I know this one's got an FTP server already installed. I know the IP, and I'll set them up. But this allows you to kind of set up a more complex scenario. You have multiple subnets like that, right? I mean, that's what I'm seeing.
Yeah.
Like you configure the YAML file, and you're
totally. It reads through the YAML file, and it builds the network. It builds the VMs. It spins up the instances based on the file that you've written. Yeah.
And then you just choose the OS from the Amazon library, right?
That would be the easiest.
These are pre-canned VMs, so they're not going to. Yeah, you would have to spend the time if you wanted to provide target-rich environments, setting up your various server services, right, and whatnot. Right?
That's true.
Right.
But you can
that too, and that would be great.
Yeah.
Take the work you've done. Rave has got all of these VMs, right? As long as you have a dream start. So this folks out of University of Alaska, Fairbanks, and some other people, And it started as a repository for virtual machines. If you got a DreamSpark account, which used to be the MSDNAA, they'll share the Windows VMs with you. And so perhaps somebody's already set up a domain controller with 10,000 accounts, and it's running FTP and HTTP and all these services that are meant to be attacked. Then you could import that in here and then use this process to spin them up in AWS. But these are just pre-canned VMs with no service
that we're running.
That's right.
Yeah.
Yep.
We've experimented with running other VMs as well, and we've customized them for specific scenarios. This scenario, they're just very basic because it's just a network discovery exercise.
Sure.
But yeah, you can fully customize everything. You can import VMs using Amazon's interface, and that would let you just spin up tons of exactly the same configuration or however you want it to be, really.
And can you Chris, and you guys, you got grants. Can you talk about these Amazon grants? And
maybe Richard Weiss on Skype can answer this, but I think you just can ask Amazon, and they ask how many students you have, and then they give you so much credit.
Yeah, you email, if you Google like Amazon education grant, you email them, they'll give you $2,000 worth of credit.
$2,000.
Yeah, $2,000 worth of credit. And but you have to have a credit card. That you just have to monitor that. I did a poor job.
Okay.
That was my own fault, but yeah, it's a great program. Thank you.
Yeah, it's like an educator sponsorship type thing.
2,000 credits.
$2,000. Basically,
of course,
use any Amazon services. Is it per course or just like one?
I did change it, but sometimes it was even for students. It says how many students you have. Oh, that's why we give you so much.
Yeah. And then next semester, yes.
Right.
It's a great deal. Now, how did you handle, like, they have certain rules if you're going to do pen testing or scanning? Do you notify them, or do you just kind of...
Yeah,
I think we asked them in the way that we have it, that we had, this one subnet, that we scan only, inside our 10.0.0. So we first got to stretch 16, and we scan half of that there.
I'm just kind of let them know.
And I think, so again, this will be a question for Richard, who unfortunately my Skype doesn't go through right now.
We've talked to Amazon about getting like a ethical hacking type carte blanche.
Yeah.
And I think that we're in the clear, and I imagine that it wouldn't be too difficult as an educator to get the same kind of setup.
And did you set up a Kali or a backtrack AMI or no? Or did you do that off the screen?
We don't have a Kali AMI currently set up, but in the past we had a couple different VMs running Kali among them. Yeah.
Okay. And EC2 or so?
EC2. Oh. It's just a matter of importing them.
Yeah.
You can import, I think, VMware images, and so we just did that.
Yeah. We might have 2 more slides, but I think I like the discussion, and we're going to end the discussion, I think. Let's see how many slides we have. So this questionnaire is just for our third-party NSF evaluator, and so I know there's normal conference feedback that you can give and get a raffle ticket in an hour or so, or right now even, but this is just for us. It would be great if you could take a minute before you run out. But there is the GitHub one where you can totally talk and get our code. I mean, it was a couple of weeks or months for us to actually figure out YAML and Chef or whatnot, but it was many students like Miles. I didn't do that much. I was just the project manager a little bit and grant writer or whatnot, so we got a little bit of support to pay the students to do this, but this pretty much was a student project.
Yeah, sorry, this is somewhat illegible. SBOESEN/EDURange.
So that's the other student.
That's a student who contributed quite a bit. Hosted the project on his GitHub. And so you can fork it there. The install details are a little tricky. We don't have like a formal documentation prepared yet, but we're working on it, and you're welcome to ask us any questions, and we can help you out.
And did you capture like the cost, so to demonstrate to you could say, hey, I taught this class, and it only cost me $32, right? Or,
it's way less even.
Yeah, that's what I mean, right?
Yeah, it's cents per hour per machine.
Yeah, our university, our IT people, they want to buy more stuff, and it's just like, if I buy more stuff, if you could do it, here.
Yeah, and that's why virtualized systems that other people host
So we were looking at
Very convenient.
4 GPU machines. I think they got the 4 GPU machines.
Yeah.
They're $2 an hour.
Yeah, it's crazy what you can do on AWS for cheap. Yeah. I think virtualization is definitely the way to go for classrooms. You can just have thin clients and interface to like really hefty VMs if you need them, but oftentimes you don't.
All right, so EDURange in and of itself is a bunch of Ruby scripts.
Yeah, okay.
Okay, it's Amazon's interface.
Yes.
Or it's interfacing with Amazon.
Yeah. So we have. Yeah.
Okay.
Did you look like CloudFormation and other stuff? I mean, you can do a lot of automation with. You need to go like this, right? Or apps. It's just auto deployed.
I'm not familiar with CloudFormation.
It's basically, it's like building a stack of VMs and hit one button. You know, so they can pull from the chef or the puppet.
Okay, that sounds similar to what we're doing. I'll look into that. Definitely. Any other? Sorry?
We're done.
Okay.
We're out of time, but if you guys have other comments or suggestions for us what games to do next, or whether you think this is useful and you want to grab it from us, I think we had fun developing it, and this is pretty much the beginning, and we still have another year or so to work on it some more.
Good job.
Thank you.